start off, I am going to use the disclaimer. Unlike the popular jokes that are out there, this nutritionist does not claim to be a veterinarian. So I'm just going to get that out there first. But I will talk through this today. A lot of my background in my PhD work was on immunology and molecular virology and bacteriology. So hopefully I can relate to the veterinary team in here. Doug had asked me to talk today. I had worked with our veterinary team over the last few years trying to work through rotavirus in our system. So there was a group of us who meet on a regular basis and try to work through how are we doing, what's going on, what are the new vaccines coming out, and how do we address the issue. So I'm going to share with you, of course, today what we have found. So as Doug alluded to today, there are 3 different groups of rotavirus that we focus on. In the pig industry, obviously A, B, and C are the ones that we're most interested in. For many years, when I came to our system, our primary concern was rotavirus A. And back in 2010, we had started to notice that there were additional cases of scouring on a farm where we just weren't really getting a lot of control. And so we went ahead and, of course, ran our diagnostics. And at that time, rotavirus A was no longer the only issue we were chasing. We realized we now had rotavirus C as well. So the vet team at that time went into mode, and they went through a lot of natural plant exposure, or what people would traditionally call feedback approach, to try to remove A and thinking C would go with it following that program. And 4 months later, as we reassessed the situation, the scour level was reduced, but it was still present on the farm. And in fact, rotavirus A had disappeared out of that farm, but rotavirus C existed still at that point back in 2010. And during that time, there were a lot of discussion points on whether or not rotavirus C was even an infectious product, if we should really be concerned about it in terms of creating a clinical disease and one that we would associate with pre-wean mortality. Well, as we tracked this in 2011 through that farm, what you'll see is that there were periodic spikes of over 20% pre-wean associated with that rotavirus C on that farm. And if this black line is our goal, or our target level for pre-wean, there were very few months where we actually met that goal through that whole year while we were trying to address rotavirus C. Well, rotavirus C, as we learned through that process of natural plant exposures that we were using, was not providing the same amount of protection or the type of protection that we would have seen with rotavirus A. We worked with a variety of researchers and autogenous vaccine manufacturers over the course of a few years, and while some of the rotavirus vaccines did show initial promise, they didn't last very long for us. And we know that growing it in the lab is difficult, so coming up with a killed vaccine, modified live vaccine at the time was not something we would consider. So we shifted to subunit vaccines. And subunit vaccine with rotavirus C also showed some promise. But again, over time, we lost its efficacy, and rotavirus C and pre-wean mortality and scour incidence again rose. And I did not put the slide in here, but much like what Dr. Marthaler was showing on the dendrogram, when we started looking at what we were seeing in our system, we had a wide variety of strains that were occurring on a single farm. So while the subunit vaccine might be working for a specific epitope, it may not have been working for another version of that epitope in a different strain. And so our cross-protection was lacking. So that led to multiple other discussions. But then what happened that stopped all that discussion, of course, was PEDv back in 2014. So when PEDv came to the farm, obviously rotavirus C symptoms lessened. And that's pretty much a no-brainer. We don't have a reservoir on the farm when there are no baby pigs, so of course there's not going to be any rotavirus C that's going to be there. However, after PEDv cleared and we were producing PEDv negative pigs by PCR, and the farm was deemed PED stable, we did not recover rotavirus C for an additional 6 months after that point. So rotavirus C, for whatever reason, was slow to come back into those farms that were having issues prior to PEDv. And the question was why? So we started a series of lists to try to understand what was different between before and after. So prior to PEDv, the farrowing houses were, of course, washed and disinfected prior to bringing in new pregnant sows. And natural plant exposure was conducted on a group that was getting ready to come into farrow, so on a weekly basis, just one group at a time. But during PEDv, some additional processes were changed. We added additional sanitation in the farrowing house. But the key that we really felt made an impact was we did whole herd natural plant exposure, and we conducted it multiple times. Because the goal during PEDv, as everybody remembers, was to minimize the amount of environmental contamination that was present in that facility, so that we did not overwhelm that immune system when those piglets were born. The other thing we noted during PEDv were the gilt litters appeared to be more susceptible during an infection. And I think we can all recognize that. We understand that gilt litters, even in the wean to finish barns, have a higher rate of mortality. So there is some immune compromisation that occurs with the gilt herself and what she transfers to that offspring. And then finally, we talked a lot about timing is everything in these processes. So when are we doing these exposures and how often? All went into that discussion. So today, I'm going to lead you down 6 key points or 6 key areas that we focused on as a group, and then I will show you what our process is today, and I will also share with you where our outcome is currently. And I think it's important. I could show a lot of slides on where we're at and how the trends have looked, but for you to go back to your systems, your production groups, and implement information, I want to make sure we have a basis. And so that's what we're going to focus on today, are the basics and the principles behind what we did. So hopefully you can take that back and use that in your own groups. So the first thing I want to think about, or want you to think about, is we're doing sow to piglet immune transfer. We're not injecting a pig and having an immune response in the one pig. We're actually working with the sow, and she's actually the media that's then transferring immunity to her piglet. And so we're not going to be on the piglet level. We're going to be on the sow level today for most of the time that we're talking, because that's what's important, and that's what's going to drive protection. So we know that the primary source for rotavirus infection is in the ileum. And after a rotavirus infection, what we find is there are a high number of intestinal IgA, rotavirus-specific primary secreting cells, and memory B cells. We also know that we get short-term IgA memory B cells present in the ileum, but the IgG cells are actually located in the spleen. So we have 2 different populations of memory cells that we're looking at, and they're in 2 different locations in the animal. When we think about the process that's occurring, we need to think on it, of course, on the enteric level, because that is where this pathogen is located. When a sow is pregnant, and of course at any time, at any point in our lives, what we have occurring at the lumen surface is a series of immune activities on a daily basis. But the one we want to focus on is the dendritic cell, because the dendritic cell is quite critical to the process that we're going to talk about today. This dendritic cell reaches through the tight cell junctions, and it samples the lumen of the intestine. And what it's doing is it's searching. Every day it's searching, and it's in a series, in a generic sense, it's counting. It's counting what it's finding in terms of bacteria, it's counting what it's finding in terms of virus. And the more hits it has on a specific virus, that of course is going to create different signals, and eventually, if there are enough hits, this dendritic cell is going to call in the troops, and we're going to mount an immune response. Okay? So what we want to try to do with our sow is we want to get this dendritic cell to recognize that rotavirus is present at a high enough level that we should mount some type of an immune response. But we don't want to overwhelm the sow and create a true inflammatory reaction or clinical symptoms in that sow. So that's the process we're going to work through today and how we're going to get there. The other part of this relationship I want you to think about in terms of sow to piglet is prior to farrowing, the sow has, of course, the enteric mammary relationship. So how are we going to get immune cells in the ileum to get to the colostrum? And so what happens are IgA, pre-plasma cells, T and B lymphocytes migrate through this enteromammary axis. And this happens in approximately 1 to 3 weeks pre-farrow. So anything you're thinking about doing in terms of what you're doing for immunity for that piglet needs to happen prior to this 1 to 3 weeks. So prior to those cells migrating to the mammary system. We also need to recognize that piglet is born immunologically naive, and it is extremely dependent on acquired immune protection. So what is it getting? Well, in colostrum, of course, it's getting some IgA and IgG. IgG is going to be predominant in colostrum, and then within 12 hours, we start to see the switch to IgA and milk. We also are going to get leukocytes, and those leukocytes will transfer through the lumen into the serum and then recirculate to that piglet's tissues within 24 hours after consuming the colostrum. But as others have shown, Tubely and even Molitor have shown that these leukocytes are dam specific. So we need to make sure that those piglets remain on their sows for the first 6 hours of life so that they can get that leukocyte transfer that's going to happen. If we transfer that pig too soon, those leukocytes never cross the border. And we'll lose that opportunity for some of our specific cells to get into that piglet and provide the necessary protection. And there are other immune components that are going to go into colostrum and milk, but we're not going to talk about those today. And lastly on this slide, I want you to remember that when we talk about passively acquired immunity, and we're talking about enteric immunity, IgA is going to be the predominant antibody we're going to focus on. But I'm going to show you a slide here in a minute where IgG is also important. And the group in the office makes fun of me because this is my monkey study, and I'll refer to the monkey study a lot when we talk about rotavirus. But this study was done where they took the cats and they either gave them a high, an intermediate, or no IgG through an IV, no specific to rotavirus. They then exposed those monkeys to rotavirus. And what they found were the monkeys that never received any IgG, of course, developed rotavirus within 1 to 3 days and shed it for a period of 6 to 8 days. But those monkeys that did receive IgG in some version either had no shedding or reduced shedding. So even though we talk about IgA, IgG, which of course, as I just told you, was in colostrum, is also an important factor when we're talking about immunity. And we know today that killed vaccines generate a great IgG response. But I just told you too that IgA is our primary passive protection for enteric immunity. So how do I get IgA? Killed vaccines work great to get IgG, but how am I going to get IgA? Well, if we look at Linda Safe's work and a couple of other individuals' work on TGE, what we found was we needed the ability of the virus or the vaccine to infect the enterocyte to elicit the IgA response as well as the IgG response. So when we think about those subunit vaccines, or we think about even with PEDv, and Linda Safe talked about this a few years ago, we need to have the natural exposure. We need to have a live or a modified live exposure to develop the IgA response first. And then you can use those killed vaccines or the subunit vaccines to develop the IgG response. And putting those together marry a nice overall immune response. The last thing I want to talk about before I show you the process that we're doing today is a little study that we did on rotavirus A last year. One of our interns went into a farm. They were only dealing with rotavirus A at the time. And we went out and, of course, did a whole herd natural plant exposure as a goal to try to minimize shedding on the farm. But what we did was we took the group that was 7 weeks pre-farrow, after they received their first natural plant exposure, and we divided them into 3 populations. So either they got no additional natural plant exposure, or they received natural plant exposure 4 weeks pre-farrow, or they received it 2 weeks pre-farrow, because we wanted to understand the timing. And what happened was there were no significant differences in scour incidence, but we looked in terms of pre-wean mortality, and we had a pre-wean mortality response when we gave that second exposure at 4 weeks pre-farrow. So we recognized in this situation we needed to have a minimum of 2 exposures, and the second exposure needed to occur at 4 weeks pre-farrow. And again, if you think back to what I showed you on the enteromammary axis, that's because those cells are migrating 1 to 3 weeks pre-farrow. So by getting it out there beforehand, we're giving the body enough time to move those cells into the mammary gland and be ready when colostrum production is occurring. The other thing that was interesting, and this alludes back to what we saw with PEDv and gilts, is none of the gilts were shedding prior to farrowing or when they came into farrow. But they did start to shed within a week after they farrowed. So even though we have elicited protection and we've demonstrated a response, our gilts are still shedding virus. And as we know, if the environment has too much pathogen in it, it will overwhelm the immune system, and we can then, of course, trigger a scour. So this is something for us, for a little bit later we'll talk about, but an interesting piece of information that I wanted you to keep in the back of your mind. So we walked away after putting all this information together with 3 key areas that we look at when we talk about good natural plant exposure. And that is what we do today in our system, is natural plant exposure for rotavirus C. So we look first at the time exposed to reduce shedding in the farrowing house and to allow for that cell transfer to the mammary prior to farrowing. So we're going to do this just like the rotavirus A work I just showed you, where we're going to do multiple exposures to elicit a strong memory cell response, with the last exposure occurring 3 to 4 weeks prior to farrowing. The second thing we're going to do is provide natural plant exposure with live virus as the first exposure, and then you can either use the second with NPE or you could go with a vaccine if you choose. But the key here is good log numbers per mil. And I'm going to stand up here and say, I don't know what that number is, because with rotavirus C today we do not have quantitative PCR. We have some very nice work that shows models of how much we can use on rotavirus A, but until we have those relationships, the best I can tell you is the lowest CT value you can get is what you're going to want to use for natural plant exposure. The other thing we've learned along the line, because we have groups that use feed disinfectants, and we have groups that use chlorine dioxide and different things in the water, is make sure that the media that you're mixing your natural plant exposure material in does not contain either of these, because it will reduce your effective logs of live virus. And then finally, minimize the environmental exposure. So of course, good sanitation. But the key here for us was whole herd natural plant exposure. So no more going in 1, 3, 4 weeks prior to farrowing and giving just that 1 week's farrowing group a natural plant exposure. We do whole herd natural plant exposure today. So what do we do? The live virus is collected from the facility, from affected animals, and then we're going to use that as the first exposure for the population, and then either we'll do the second with the live virus or with the vaccine. This regular whole herd natural plant exposure occurs every 4 weeks, with the last one occurring 4 weeks prior to farrowing. And this, of course, will allow that time for those immune cell migrations to occur to the mammary gland and get adequate antibody response. And then when the piglets are born, we're going to focus on good colostrum intake with those piglets on their original mom for a minimum of 6 hours. And we're going to make sure that environment is clean and warm. And our production team has done a great job. They've made some ventilation adjustments. They've gone down to the micro level for the pig and made some additional adjustments as we started this program approximately 8 months ago. And where are we at today? Well, today our system has had an 80% reduction in rotavirus scours and incidence in the system. There is still a population, as I alluded to, where environmental exposure is going to override the passive immunity. And that sounds like a lot, but when you look at the human literature, it's the same. Even in humans, whether it's a live exposure or a vaccine, there is not 100% protection. And if we go back and we look at those dendrograms, it's truly probably because we have not as strong a cross protection against all the different strains that are out there. And that's why we use natural plant exposure as well, because we are right there at the farm. So if the strain is shifting on the farm, we're gathering the most recent strain that the farm is currently experiencing to mount that immune response. But we still do ask the question, why? Why is this not 100%? Why is this not perfect? And why are our gilts appearing to be the ones that are most affected? And that's what we're chasing today, of course, is the why. I believe that what's happening with the gilts is we probably don't have as good of a mammary efficiency on that first farrowing. So what does that mean? Do we change something prior to puberty? Is it something post-puberty? What are we going to do to help mount that immune response and then, of course, get sufficient transfer from the enteric system into the mammary gland for those offspring?